Have you ever wondered how your Google search, WhatsApp message, or your favorite Netflix show actually travel across the internet to reach you in seconds? Behind all of this magic, something called OSI model. We are going to discuss very important topic, that is OSI model in the computer network. Everyone should understand the OSI model because it is essential for understanding of how computer network works and also very important for interviews. So prerequisite for this video, please watch the previous videos because we have started this network playlist in a structured way. We are going to use some concept in this video, so where I explain those concepts in the previous videos. If you watch those videos, it will help you to understand the OSI model much better. I have decided that I will explain the OSI model in deep dive. And also, this is going to be very interesting. We are going to learn in different and easy to understand way. Please make sure that watch the video till the end. So without wasting any time, let's get into the OSI world. Are you guys ready? Yes, the first question you should ask is why we need to study the OSI model. If you look at the history, which I don't go in detail here, since I already covered in my history of networking video. Okay, so in the earlier days of internet, companies like IBM, Cisco and HP had their own network communication. If you had an IBM computer, if you want to communicate with the HP, okay, it couldn't. Why? Because each company spoke own network language. So the big question was, how do we make all these different systems communicate in a single or common way? That's when the OSI model was born. The OSI model provided one common language for every network. No matter which company built these devices, as long as they followed the OSI model, they could communicate with any other device across the globe. That's why OSI model is so important. And it's just not a theory, it is the foundation of the networking, which is used to design, build and troubleshoot networks even today. Okay, now we understand the why we need the OSI model. Let's understand the what is OSI. Okay, OSI stands for Open System Interconnection Model. It is a conceptual framework that describes how data moves from one computer to another computer across the network. Think like it's a blueprint for networking that explains how computers communicate with each other in structured way using 7 layers. How many layers? 7 layers. Okay. Now we are going to cover the 7 layers of the OSI model. Each layer has different functionalities. But here the thing, how are we going to cover them? And more importantly, how do we make sure that those concepts stay in your mind very strongly? For that, let's take different approach. Instead of simply explaining each layer one by one, let's build network together. Imagine we have a project. The requirement is that we need to communicate with a website that is hosted in another country. But to make communication possible, we are going to use OSI reference model. But remember, before reaching that website, we must travel through the 7 layers. So let's build each layer step by step. At the same time, understand the importance of each layer, making that communication possible. Okay, let's begin with the very first one. That is physical layer. You may have a question, why we started with physical layer? The reason we started with the physical layer is, no matter which devices or software we are using, we ultimately need a physical connection between the devices. Okay, so the physical layer is the first layer of the OSI model. It's all about the actual physical connection between the devices. For this, we use different transmission mediums such as wires, cables, radio waves that carry your data to the destination device. To communicate with a website or another computer, we first need physical connection. The devices at this layer deals only with raw signals in the form of bits zeros and ones. And also we use different types of connection at the physical layer. Those are copper cables, fiber optic cables, then wireless networks like Bluetooth, cellular networks. So these are the different types of connections at the physical layer which we use. Okay, let's understand the functions of the physical layer. Okay, we will start with bit transmission. What is bit transmission? Our computer stores the data as zeros and ones. When the data reaches at the physical layer, it is converted into signals such as electric pulses, light signals or radio waves, which are then sent across the physical medium. So the main job is it's convert the signals into electric pulses or light signals across the physical medium. Okay, then move to the next one, that is data rate. Physical layer also defines the data rate or bandwidth. So that is how many bits can be transmitted per second. You might often hear terms like BPS, Mbps and Gbps. Okay, so these are the measurements of how fast bits are being transmitted. If you want to check the speed of your internet, there are many websites we can use. See, it will tell you the internet speed of your network. See, my internet speed is 240 Mbps. Okay, then move to the next one, that is physical media specification. It tells that what kind of medium is used for transmission. As we discussed earlier, copper cables, fiber optics or wireless technology depends on the project requirement. Okay, this is also one of the function in the physical layer. Then move to the topology definitions. The physical layer also defines the physical arrangements device in a network, known as network topologies, such as bus, star, ring or mesh. If you don't know about the network topologies, you can watch my previous videos where I explained everything about the network topologies. Okay, then move to the synchronization. What is synchronization? It ensures that sender and receiver align in the terms of bit timing. So the streams of zeros and ones is correctly understood. Let's imagine there is no synchronization between the two devices. Obviously the data transmission would fail. Okay, then move to the final one, that is error detection. So this is all about the physical issues such as signal loss, noise or cable faults. It can be detected in the physical layer. So this is all about the functions of the physical layer. For better understanding, what we will do, how physical connection works across the world, let's look at something interesting. If you want to communicate with another country, you need a physical path that connects your data across the continent. And most of the time, that's happened through the submarine cables. Yes, the real fiber optic cables that are laid down under the ocean. Okay, so there is actually a website called Submarine Cable that shows how countries are connected with these cables. Let me open that website. So if you open that, you see an interesting image how our world got connected through submarine. So this is how we connected across the globe. When you type a website that is hosted in another country, your request often travels through thousands of kilometers under the sea through the submarine cables, which carrying the light signals at incredible speeds. So without this physical connection, the internet as we know it, it would simply not exist. So this is all about the physical layers. Okay. Now we have built the physical path from one source to the another source. Okay. Now we have built the physical path from one source to the destination. It's time to move to the data link layer, which is the layer of the 2 of the OSI model. What is data link layer? What does this layer do? In simple word, if we can say, it makes sure that the data sent from one device to another directly connected device is a reliable and error free. Let's bring it back to our project. You typed a website URL that hosted in another country. Your laptop has turned your request into raw bits. But hold on, how does it know which nearby device talk to first? That's exactly what the data link layer handles. Let's see the functions of the data link layer. The first one is framing. Okay, so the raw bits is coming from the physical layer are packaged into frames. Okay, each frame has your data plus some extra information like source and destination address. So how frame looks like? Header, packet and trailer. In header, you can see the information like source MAC and destination MAC. In packet, you can see the actual data. In trailer, you can see some error codes that will be calculated by CRC. Okay, so this is what make the communication reliable from one device to the next. Okay, next move on to the next function, that is physical addressing. Each device has unique MAC address. Okay, so the data link layer tags each frame with a sender and receiver with a MAC address. This way, your laptop knows exactly which device to send the data to the next, like sending a package the right house in your neighborhood. Okay, move to the error detection and correction. Ever wonder how your device knows if the data got messed up along the way? That's where cycle redundancy checks comes in. CRC. What does it do? The sender calculates a small code based on the data and appends it. The receiver does the same calculation. If it is matches, great, everything is fine. If not, the data gets resent. Okay, let me take one example and try to understand in better way. Let's imagine you are sending a data 1101. Then CRC nothing but divisor is 100. So once you send the request to the receiver, now receiver check the data. How does it check? He will divide by divisor 100. If it remains is 0, which means the data perfect. If you see the remainder is something number, which means the data gets resent. So this is how CRC works. Okay, next move to the flow controls. What is flow control? Flow control is a technique used to match the speed between the sender and receiver, so that sender does not overwhelm the receiver with too much data at once. Imagine you are pouring a water from jug into a glass. If you pour too fast, the glass will overflow, obviously. Similarly, in networking, if the data is sent faster than receiver can handle, packet will be lost. Okay, so this flow control prevents this one. So this is basically making sure that sender does not overwhelm the receiver. So it controls the flow between the sender and receiver. So this is all about the data link layer functions. Okay, so back to our project story. Now our data has safely traveled through the data link layer. We framed it, addressed and checked for the errors. Now it's time to move to the layer 3, that is network layer. Then what is the network layer? Network layer makes sure that your data can travel from one network to another, even they are completely different sides of the world. If you want to reach a website hosted in the another country, your laptop has already prepared the frame, tagged it as a MAC address and send it to the router. Now the router needs to figure where to send it. That's where the network layer comes in. Now let's see the functions of the network layer. The first function is logical addressing IP address. Unlike MAC address, which is tied to device physically, but the IP address is logical. As soon as the request comes from the data link layer, we will attach the IP address to the request. It tells the network where your device is in the world and where the destination device is. Think like a house address that tells the postal service where to deliver the package. Okay, so we will add the IP address to the request in the layer. As soon as we added the IP address, then we will do routing. So network layer uses routers to move the data from one network to another. Think of like this. If you want to travel from one place to another place, you open your Google Maps and you choose the path from least traffic. The same way, router look at the destination IP and find the best path to send your data to the destination server. So this is how your request can travel across the multiple countries through different ISPs under the sea cables or the data centers. So once we done the routing, then packet creation. The data is broken into smaller pieces called packets. If you observe, in physical layer, we call the data as a bits. In data link layer, we call it as a frames. In network layer, we call it as a packets. Okay, so the data is broken into smaller pieces. So each packet carries the source and the destination IPs. So once the packet reaches to the receiver, it can be reassembled at the destination. Okay, we are covering with an example of accessing a website that is hosted in another country. To access that website, what we have done? We just built one physical path from one source to destination by using different physical cables. Then we built the data link layer to reach our data safely, and we framed it, and we added physical address such as MAC address, and also we checked for errors. Then we move to the network layer. In the network layer, what we have done? We have added the IP address to the request, and also we found the best path to reach the destination. Now here the question, how do we make sure that the particular data actually arrives correctly without missing anything? That's where we need the transport layer. What is transport layer? Transport layer is the heart of the OSI. Why do we say it's the heart of the OSI? The reason is, whatever data you are sending, the transport layer makes sure that the data reaches safely and accurately, and in order from one device to another device without any loss. It gives you guarantee. That's why we say the transport layer is the heart of the OSI. Let's see the key functions of the transport layer. The first one is segmentation and reassemble. Once the transport layer takes the data, it's break into small pieces. The small pieces we call segments. If you remember, in every layer, we call the data in different terminology. In physical layer, that is raw bits. In data link layer, we call it as a frames. In network layer, we call it as a packets. Here, we call it as a segments. You may have a question. Why we are breaking the data? The reason is, we cannot send all the data at once over a network. And also, if you break down the data and any segment is lost, you don't need to send the entire data again. You can only resend the data particular segment. When we segment the data, we give each sequence number. This make it easy put the segments back in the order. So we divide the data into small chunks called segments, and we provide the sequence for each piece. Then we send it to the receiver. Once the receiver gets the data, by seeing the sequence number, he will reassemble the data and receive it correctly. So this is one of the important function of the transport layer. Okay, next move on to the multiplexing and demultiplexing. What is multiplexing? At the sender side, it combines all the applications and send them over a single connection. This is called multiplexing. For better understanding, imagine you open your laptop. Okay, you use Google, you use YouTube, and you open a WhatsApp at the same time. Okay, So what multiplexer does at the transport layer? It is combine all the data, send it to the receiver over a single network connection. Instead of making separate connection for each application, it will send the over a single connection. That is called multiplexing. Okay. Now let's discuss demultiplexing. What is demultiplex at the receiver side? Once the data is received, it makes sure that the data goes to the respective application. Taking the same example, if we send the data like YouTube data, Google data and WhatsApp data, once the receiver gets the data at the transport layer, it will distribute the YouTube data to YouTube, WhatsApp data to WhatsApp and Google data to Google. So this is how multiplexing and demultiplexing work. So this is also one of the function TCP. Okay. Next move on to the other one, that is error control. What is error control? The transport layer also take care of the errors. So how does it handle error control? We all know that at the transport layer we use two protocols. You might have heard the terms like TCP and UDP. In the TCP protocol, which is a reliable protocol, it has a different functions. Okay, it can detect errors and also it can detect duplicate packets and lost segments. We'll talk more about the TCP in detail, where we cover the TCP IP protocol in another video. We'll cover complete packet analysis. Okay, as of now, you need to understand when we use TCP, it takes care of error detection, duplication and packet loss. It makes sure that data doesn't have any errors. If we use UDP, okay, it won't take care of any of these things. Okay, we'll talk more about what TCP, what UDP and what is the difference between TCP and UDP in the future class. Okay, so this is one of the function. Then move to the final one, that is flow control and congestion control. First, let's understand what is flow control. Flow control makes sure that sender does not overrun the receiver. Okay, let's take general example and try to understand in better way. That is a general example. Okay, imagine you are talking to your friend and you are talking very fast, but your friend is unable to catch you. So what do? You slow down your pace and talk to him, right? In the same way, TCP uses sliding window concept that control how flow between the sender and receiver. So this is all about flow control. Now let's move on to the congestion control. What is congestion control? Congestion control makes sure to control the congestion at network level. Okay, we all know that sometimes many users send their data at the same time. Obviously, network will be overloaded. If you keep sending the data at the same time, packet may be lost. Okay, for better understanding, let's take general example. Imagine you are traveling on the road, and if there are no traffic signals, while many people are traveling at the same time, obviously road will get blocked, right? The same way, technically, the network gets overloaded. To overcome this, TCP uses different algorithms to handle this situation. We'll talk more about in the TCP IP protocol soon. And a lot of people get confused between flow control and congestion control in the transport layer. If we put in simple way, flow control is the between the two devices, between the sender and receiver, while congestion control is the network layer. Okay, so this is all about the transport layer. Okay, now we have to say thanks to the transport layer. Your request will arrive at the web server correctly and reliably. Ready for the next step. Okay, now we are going to discuss other layers. Basically, this layer actually decides how the content will be displayed on your laptop. So now we have reached the session layer. What is session layer? Session layer is the fifth layer of the OSI model. It is used to establish a session, maintains it and terminate the session between the sender and receiver. Okay, think like a session layer as a meeting organizer or coordinator for communication between your device and the server. It establishes session, basically conversation between a laptop and website server. Okay, back to our project where we are requesting website that is hosted in another country. Now we have done everything. We built a physical path, we built a data link layer, and we built a network layer to find the best path. We also built a transport layer. So whatever the data you're sending, it makes sure the data goes safely. Now what does the session layer do here? Your browser asks the server to start a session. Then server acknowledges and open a logical connection, like a shaking hands before starting a conversation. As you browse the website, the session keeps track of your interaction. For example, you open a website and log in with your credentials, or you are filling a form. If the session time out or you log out, the session time ensures that the connection closes proper. So this is all about the session layers. Let's see the functions of the session layer. The first one is session establishment. It's very simple. It starts the communication between the sender and receiver. Then once the session is started, it makes sure that session stays alive when the data is being exchanged, right? Then session termination. Once you have completed your task on server, it's end the session to avoid leaving any connection open. Okay. The next one is synchronization. What is synchronization? It uses some checkpoints to help resume a session if there is a failure. For example, if your network drops for a seconds, the session layer can resume from the last checkpoint instead of starting a over. Right? So this is all about the session layer. So the session layer makes sure that your laptop and server talk to each other properly and maintain the conversation to handle interruption. Okay? Alright. Now we have reached to the other layer, that is called presentation layer. That is the sixth layer of the OSI model. What is presentation layer? The presentation layer is the sixth layer of the OSI model. It acts as a translator between the application layer and lower layers. Okay? For better understanding, let's take simple example. Imagine you are attending one meeting. People are joining from the different countries and you are not understanding their language. So what do? You ask someone who can translate that language, right? The same way, the presentation layer does the same for data. For better understanding, let's see the functions of the transport layer. The first one is translator. Okay. So the translator changes the data from one format to another format. So both sender and receiver can understand it. Let's take an example. You are sending an image in the JPEG format. The presentation layer makes sure that your browser can understand and display it correctly. Okay. The next one is encryption and decryption. What is encryption and decryption? Encryption converts your data, some plain text into different format that is cannot read by attackers. Okay. The presentation layer use some cryptographic protocol such as TLS SSL to encrypt the data to prevent from the attackers. So once the receiver receives the data in the form of unreadable format, then they use a decryption to convert it back and readable format. We will talk a lot about encryption and decryption in the cryptography section. Okay. So the next one is compression and decompression. When we use compression and decompression, so if the data is large, the presentation layer compresses it to make it to transmit faster. So once the receiver gets the data, then it is decompressed so the receiver can see it properly. So these are the main functions of the presentation layer. So this is how your data get prepared and presented in a browser. So when you visit a website, this layer ensures that images, text and videos are displayed correctly and your sensitive information is encrypted while traveling across the network. Okay. So this is all about the presentation layer. Finally, we have reached the application layer. What is the application layer? Let's look at the definition of the application layer. Application layer is the seventh and topmost layer of the OSI model. In this layer, the user can interact directly, which means it acts as an interface between the user and other applications such as Gmail, web browser, etc. For better understanding, let's see the functions of the application layer. The first one is providing services to the applications, which means it offers network services to the application where the user can directly interact. For example, opening a Gmail, opening a web browser or any other application. Okay, then move to the next one, that is resource sharing and remote access, which means it allows the users to share the information and also they can access devices remotely using different protocols. Typically, we use SSH protocol. Okay, the final one is the protocol support. We all know that application layer use many protocols such as DNS, HTTP, HTTPS, etc. Don't worry, we will talk more about the protocols in the TCP IP protocol suite. In simple terms, if we can say, application layer is where the user can interact directly with the network and share file and access resources. So when you visit a website, this layer creates a request, and when the server responds, it delivers the content you see on your screen. Okay, so this is all about the application layer and all the layers and their functions. Okay, what we will do now, we will quickly recap using our example how our request passes through all the layers. It will give you the summary of all the layers. Here you also need to understand very interesting topic, that is encapsulation and decapsulation. Okay, we will stick with the same example where we are accessing a website that is hosted in the another country. What we have done so far, now we have built all the layers. Okay, let's quickly recap each request processed with each layer by understanding encapsulation and decapsulation. Okay, so now you are open your laptop, you can see there are many applications, which means we are at the application layer. Okay, to access that website, you need one browser application, right? So you open your browser and you type the URL. Now the browser creates the message and send it to the next layer, which is presentation layer. As soon as the present layer receives the data, it translates the data, encrypt it from readable form to non-readable format, and also it's compress the data with the size is large. Okay, so once the presentation layer handle all these things, then the data move to the next layer, that is session layer. What does the session layer do here? It set up and maintains the session between the device and the server. It establishes the session, maintains it while the communication is active, and terminates the session once it is done. Okay, so now we move to the important layer, that is transport layer. As soon as the data reaches the transport layer, the data is broken into segments. The segments are added to ensure reliable delivery and also handle error detection, flow control and reliability. Once all this is done, then the data move to the next layer. As soon as the network layer receives the data, it adds the source and destination IP address to the from packets and find the best path to send the data. Once the best path is found, then the data move to the which layer? Data link layer. When the data link layer receives the data, it's flowing the packet, it's adds the physical address such as MAC address and deliver it to the local network. And also it checks for errors to ensure reliable delivery. Okay. Finally, the data reaches at the physical layer. Once the physical layer receives the data, which converts the data into electric signals, light or radio waves for transmission. The physical transmits the actual bits across the medium to the receiver. So this process of adding the data at each layer is called encapsulation. Each layer adding something to the data. Okay. Now once the data is received by the server through the physical medium, then decapsulation begins. What is decapsulation? It is the process of peeling off the extra information which were added in the encapsulation. Now we receive the data at physical layers. The physical layer receives the raw signals and then convert back into bits. Okay. Then the data layer checks for the errors and remove the frames. Then the network layer reads the IP address and take the data information. Once the transport layer has reassembled the data, the session layer ensures that communication is still active. Remember, on the sender side, we initiated a session. Now the session is still active. Next, the presentation layer decrypt and decompress the data so it can read properly. Finally, we move to the application layer on the server side. Once the server receives the original message, the process your request and respond to the sender. So this is complete flow from sender to receiver. Finally, we have achieved our goal accessing the website. This is all about the OSI model. I hope you now have a complete idea about it. And this is very important. Even if you skip any topic or did not understand something, I highly recommend you watch the video again, get clarity on the OSI model. Thank you for watching my video. We'll come back with another interesting topic in the next video. Until then, take care. Bye bye.